So today we'll be studying how we can calculate the volume of a prism. And a volume of a prism is literally dealing with a box and dealing with a pyramid. You've seen that before. Now, when we're dealing with a volume of a prism, otherwise known as a box, it's pretty simple, okay? So here's our first example. A candle is in the form of a square-based prism. How much wax is needed to make the candle? So, if you think of what the word volume really means, volume is basically taking all of the areas and kind of adding them up to make a three-dimensional shape. So, it's almost like having the base of our book look like this. And then we keep adding more and more levels to the book until finally we get a big full shape of the book in 3 space. So this is what our prism looks like. So we have the base of our prism. Notice I'm actually drawing it dashed for the back half of the prism, but then solid for the front half of the prism from the base. So there is our base, and then we have our heights. And then we have another repeated square base on the top of our prism. Now, the base of our prism has 8 inches, and its height, which goes to the back of our prism here, is 15 inches. So here's our solution. To find the amount of wax, we need to calculate the volume of the candle. All right, so here is what we do. The area of the base is equal to s squared. Remember it is a square-based pyramid, right? So s squared is 8 squared, which is just 64. So now that I've got my 64, now here's what I need you to know. The volume is going to be the area of the base times the height. So we end up having, well, 64 times 15, which equals 960. Okay, so then you say at the end, therefore the volume of wax needed is 960 inches cubed. So try to remember that when volume is inches cubed, centimeters cubed, you got to remember that, and that's your answer. All right, so here's our next example. So imagine I have this guy named Mo, or girl, doesn't matter, that wants to build a greenhouse in the shape of a pyramid, okay? Now, the dimensions of the floor are about 12 feet by 8 feet. The height is about 11 feet. The volume of the air in the greenhouse will determine the type of ventilation needed. So we need to find the volume of the air in the greenhouse. Now, here's what I'm going to do. I'm going to give you the basics to find this problem. Well, here's what we know. We know that when we were calculating the prism, remember the area of the prism was equal to the area of the base, and then we times it by the height, right? Now, for a prism, we have to do something a little different. We're going to use the area of the base still, and we're going to use the height, but the volume that's taken up is only 1/3 the area of the base times the height. So the area of the base is given by this and this. So we're going to actually substitute into this equation, and we're going to go through it very slowly. So the area of the base, so we go V is equal to 1/3 times the quantity of, this is what we put in here. We put our base numbers, which are 12 and 18. So let's put those in. We put 12 times 18, and then we must times it by what we have here, the height of our pyramid, which is 16 feet. Punching all that in, it's just 1 divided by 3 times 12 times 18 divided by 16, and that gives us 1,152. So then we say, therefore, the volume of the air in the greenhouse is 1,152 feet, and always say it is cubed, and then you're good. Answer is done. And just take a moment, go over that one more time. So remember, we took 1/3, the volume of a pyramid is given by 1/3 the base, area of the base, times the height, which is 1/3, 12 times 18, which is where we had this, and then we had our height, which was in blue here, okay? Multiply them all together, get your answer, and that's your it, and there it is. So our next problem involves finding the volume of this tent here. You'll notice that the volume of the tent really needs to have a base and then its height, and there's supposed to be 3 variables here. And what we notice we're missing here is this part here, the height of our triangle, because you know the base of a triangle, the area of a triangle is going to be the area of the base times the height, and then we divide it by 2. And we don't know what the height of our triangle is. Okay, so let's go and do some calculations to figure out all that information, okay? Now, the problem asks for how much space is there inside something, okay? So here's what you need to understand. You got to realize that volume is a measure of the space inside something. So now, to find the volume, we have to literally take this triangular shape, and we're going to multiply it by its length here. So volume is not necessarily always multiplied by the height. It could be multiplied by the distance between the 2 repeated sides. In this case, the 2 repeated shapes for our prism are the triangle here and the triangle that's alluded to in the back of this picture. Okay, so here's our biggest problem. We don't have the height of this triangle here. Okay, so what we need to do first of all is we need to calculate. So here's our solution. We need to calculate the height of the tent. So this is what our tent looks like in the front. It has 7 feet, and then it has a height that's dropped from the top of the triangle all the way to the base. Now, we're only going to use only half of the triangle. We're literally just going to use this half of our triangle because we have 7 and 7 divided by 2 gives us 3.5. So this goes to this by dividing the length by 2. Now, I'm going to let you in on a secret. Each of the sides of this tent, here, here, and here, are the same. So that means that this is 7 feet as well. So that means this is 7 feet, and this is 3.5 feet. So now all we have to do is calculate our h value, which is right here. And so we're going to use Pythagoras, which means that we have the following. 7 squared is equal to 3.5 squared plus h squared. So you end up with h squared is equal to 7 squared minus 3.5 squared, which means h squared is equal to 36.75, and h is equal to the square root of 36.75. That means our h value is going to equal approximately 6 feet. So you thought you got away from Pythagoras theorem. Sorry, dudes, you got to use it. So now let's move on to the last part of our calculation. So now that we have our height being 6 feet, we need to calculate the area of the triangular base. So the area of the base is 7 feet and the height is 6 feet. So what we're going to do is we just substitute. A is equal to base, 1/2 base times height, which is 1/2 of 7 times 6, which gives us approximately 21. So the area of the base is 21. Now, we must find the volume, which is equal to the area of the base times the height. No, not the height, but the length. So we end up with 21 times 10 from here, which gives us 210. So we now can say the volume is 210 feet cubed. And we're done. So you could say there's approximately 210 feet cubed of space inside the tent.